A rocket engine can exceed 180 decibels at launch, but above the atmosphere, its roar would not travel away through near-empty space. What exactly breaks between a violent event in space and a sound reaching an ear? Sound is not the same thing as energy. It is one particular way energy moves. In air, sound is a traveling squeeze. Molecules are pushed closer together, then spring apart, then push the next molecules along. The pattern reaches the eardrum as changing pressure. At sea level, 1 cubic meter of air contains roughly 25 million billion molecules. That crowd is why a hand clap can cross a room. The molecules are close enough that one disturbance is passed on before it falls apart. Space is not truly empty. Near Earth, the solar wind often contains only a few protons in each cubic centimeter. The average gas between stars can be thinner still, often around 1 atom per cubic centimeter. That is still matter, but it is not a crowd. The particles are too far apart to carry the rapid pressure changes that human ears detect as sound. A vibration may start at an explosion, an engine, or a collision. In near vacuum, it does not remain a continuous pressure wave all the way to a listener. Silence begins outside the carrier, not inside the event. An astronaut hears voices because the helmet contains gas. Pumps, fans, and tools make sound because the spacecraft has air and solid parts. A mic attached to the hull can record vibrations moving through metal. A struck spacecraft would not hear the impact through open vacuum. It would hear it because the impact shakes the structure, and the structure passes that shaking inward. A blast in space is not quiet because nothing occurs. Matter can be heated, gas can expand, fragments can fly at thousands of meters per second. Light and radiation can carry energy across vacuum without needing air. What fails is the ordinary blast wave. In an atmosphere, an explosion shoves nearby air into a shock front. In near vacuum, the expanding material spreads out and thins. By the time it is far from the source, there is usually no connected chain of particles, dense enough to push an eardrum back and forth. The question has narrowed to the missing carrier between motion and hearing. Space contains waves, but not every wave is sound. Electromagnetic waves, including visible light and radio, can cross vacuum. Pressure waves cannot cross empty space in the same way because pressure is a property of matter. Where matter is dense enough, space can carry pressure waves locally. Gas clouds, planetary atmospheres, and disks of material around stars are not silent in the same physical sense as interplanetary vacuum. Spacecraft sometimes return data that can be played through speakers. Those recordings are usually not microphone recordings of sound moving through vacuum. In plasma, charged particles can oscillate with electric and magnetic fields. Instruments measure those oscillations or measure radio emissions linked to them. Engineers can shift the data into the range of human hearing. That process is sonification, turning measurements into sound. It can reveal real patterns, but it is not an astronaut standing outside and hearing space with bare ears. A planet with an atmosphere changes the answer again. On Mars, microphones have recorded wind and rover noises. The air pressure near the surface is less than 1% of Earth's, so sound travels differently and high frequencies fade faster. Titan, Venus, and Earth all have atmospheres dense enough to carry sound, though each would carry it in its own way. The silence belongs to vacuum, not to every place beyond Earth. The answer is that nothing mysterious happens to the event. The break is in the space between the event and the ear. Sound needs matter packed closely enough to pass pressure from particle to particle, and most of space does not provide it. That part is settled for ordinary vacuum. What remains open is local and measurable. The exact waves in particular plasmas, atmospheres, and dust clouds we have not sampled directly. Those places may have vibrations of their own. Across near-empty space, there is no bang to carry. That's Y-Source. If this was worth your time, like it, share it, and tell me in the comments what you want examined next. If you would like to support this work, the Patreon link is in the description.